Hello everyone, welcome to my presentation about ontology-based respiratory disease database management. I call my system is Respiratory Disease Management System. For short, I call it is RDM system. My name is Lê Trường Nguyễn. First, we will look briefly at the content of the presentation. There are 4 parts in my speech: introduction, related work, proposal, and result. Firstly is introduction. This session gives us an overview of the whole system, explaining why this system is built and what it does for us. It includes 3 small parts: background, phase problem statement, scope and objectives of the system. Secondly is related work. This part will theoretically introduce useful background knowledge, helping us build this system. Thirdly is proposal. This part will guide you the steps to build this system. Finally, result show how successful we have been when applying the knowledge mentioned above. Now, I will move to the first part. It is introduction. With the non-stop development of modern society, the case of human disease is increasing, and the management of disease in hospital in Vietnam is still error, lack of accuracy, and less information. Therefore, the problem at this point is how to get a tool to solve the problem and help users manage and update the data is effective. A solution has been proposed, that is, using ontology, which contains clearly specification of the concept of a field and the relationship between the concepts. Ontology is also used extensively and successfully in other fields, including medicine. Many industrial companies and various business corporations have chosen the ontology as their platform to deal with the rise of modern information exchange. The dynamic and continuous change in the business environment result in continued customization in requirements that can only be made by modifying the elemental ontology. Ontology is like a database of a particular field. It describes everything in that field, including definitions of terms, properties of objects, and relationships between them. It will allow the computer to understand the human-like semantics to share information across different systems. And disease databases are now very diverse and increasing every day. But Vietnamese disease databases are not consistent and overlap, and leads to difficulty of update and lookup. Then I will move to an example. Here I have a well-known examples that are the same as this system. This is a popular web application that allows users search for information on a disease, system, physical site, or non-rand rut or common laboratory abnormality which is called disease database. From the above sample, it is clear that each system has its strengths and weaknesses. Disease database only allow ordinary users, not experts, to look up available information. It does not support multi-user. About RDM system. So it is great that we can build a disease database storage system which people can use for free as long as they have internet. This means that the system is completely online in parallel. The system also allows for multi-user. Normal people can quickly look up information about disease information, and the doctor can also log into the system to add more disease, handling so many tasks for editing the database. Besides that, RDM system also provide an advanced functionality that is the doctor can upload a database file to merge this disease database. And however, to build a complete system, there are many problems. Some issues I mentioned is the management of disease in hospital in Vietnam is still error, lack of accuracy and less information. Vietnamese WordNet has not yet supported, leads to semantic processing become difficult. Vietnamese patient databases are not consistent and overlap. In addition, the comparison of meaning of words and sentences in Vietnamese also make it difficult to find a suitable method. In short, my goal in building my RDM system is the normal people, I mean non-expert, can use this system to find information easily, fast, and the information is displayed in well order. Last but not least, the system can support for the expert in updating the disease list, merge new data with another one. Next, I will move to the second part, which is related work. Now, we should make clear about that workflow of the system. I divide the system into 3 steps to complete. Step 1 is building a disease ontology. That is build constructor of RDM system. Step 2 is using natural language processing to process data, giving data consistent. Use combination of methods to reset the input data. Step 3 is build a user interface that gives user friendly, easy to use, and add-on application. There are several definitions that we should take a look. WordNet is a large lexical database about nouns, verbs, adjectives, and adverbs are grouped into sets of cognitive synonyms called syntax. Each expressing a distinct concept. Syntaxes are interlinked by means of conceptual, semantic, and lexical relations. There are some important distinctions. First, WordNet interlinks not just word forms. String up letter First, WordNet interlinks not just word forms, string of letters, but specific sense of word. As a result, words that are found in close proximity to one another in the network are semantically disambiguated. Second, WordNet labels the semantic relation among words, whereas the grouping of words in the source does not follow an explicit pattern other than meaning similarity. About the structure of WordNet, the main relation among words in WordNet is synonym, as between the words such and close, car and automobile. Synonym words that denote the same concept and interchangeable in many contexts are grouped into another set called syntax. About lexical relation, we describe the lexical relation to clear the concept of synonym as well as homonym. Relation lexical concepts are difficult to define a common way. It is given by Truss in 1986. A lexical relation is a culturally recognized pattern of association that exists between lexical units and a language. Synonyms can be any part of speech, noun, verb, adjective, or pronoun, as the two words of a pair are the same part of speech. In the linguistic dictionary, the synonym is defined in three concepts: a word having the same or nearly the same meaning as another word or other words in a language; a word or an expression that serves as a figurative or symbolic substitute for another. Biology, a, a scientific name of an organism or of a taxonomic group that has been superseded by another name at the same rank. Homonym is a word whose meaning is included in that of other words. Antonym is a word which having a meaning opposite to that of another word is called antonym. Word-based model is an algebraic model to represent text, document, or any object. About phrase, paraphrase term, it uses a mathematical model as vector to define, to identify, or in that term, in the text documents. Model is useful in information retrieval, information filter indexing. The invention can be traced at the Thornton's introduction about vector space model for information retrieval. This term is due to Heinrich in 1993. Vector similarity is only information recent in workspace. Semantically related words are close, unrelated words are distant. As we have seen in the definition, the workspace model is model of semantic similarity. On the other hand, the geometric metaphor of meaning is meanings are location in a semantic space, and semantic similarity is proximity between the location. The term document vector represents the context of term in low granularity. Besides, creating term vector according to the sum works surrounding to compute semantic vector. It is a kind of semantic vector model to compare the semantic similarity in semantic vector model. We use cosine distance, a document term matrix and a term document matrix, and a mathematical matrix that show the frequency of term occurrence in a set of connected documents. In document term matrix, rows correspond to document in the collection and columns correspond to term. In the term document matrix, row correspond to work, or term and column correspond to document. We also can use TF-IDF ways. Then we move to the third part, proposal. Ontology in the field of disease describes the concept of disease terminologies and the relation between them, thus enabling the sharing of disease knowledge. I have so many steps to successful build on disease database ontology. First is planning concept, estimate outcome and future consideration. The second is gathering relevant research, tool and database. Together is the tool I use. Step 3 is defining term and relationship in disease ontology. 4 is creating ontology structure. After this step, I have disease ontology prototype. Finally is testing ontology using tool and check if there are many errors in structural design or functionality. If yes, I fix the errors to enhance the ontology prototype. If there is no error, we add. It means that we have the final disease ontology. About the semantic processing. Semantic processing is processing that occurs after we hear a word and encode its meaning. Semantic processing causes us to relate the word we just hear to other words with similar meanings. Once a word is perceived, it is placed in a context mentally that allows for a deeper processing. This is just definition of method of comparing the similarity between words and sentences. The implementation is still in process, so temporarily there is no demonstration for this part. I'm sorry about that because I'm using a new framework, so I have a problem with connect between backend and frontend. The proposal result is first, search. The data will mark with keyword that user input. The second is merge. New data will be merged from all data and the input one by user. The third is update and edit. Data will be updated after doctor edit information. Thank you for listening.